Okay, the first Ferris wheel was built by a bridge builder named George Ferris. The diameter of the wheel was la 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 la. They give us a lot of numbers. If the wheel rotated every 9 minutes, use the data in the table to sketch a sinusoidal graph which represents the height of a car in meters. Okay. Well, before we get into drawing a graph, let's see what we can find for numbers on this thing. If this is a sinusoid, then it ought to have an amplitude. It should have a period and hence a b-value. It may have a horizontal phase shift, and it should have a median value. Let's see if we can work any of those out. They say the maximum height of the Ferris wheel was 80 meters. And the bottom of the wheel, well, they don't say where the bottom was, but they tell us indirectly. They say that the diameter of the wheel was 76 meters. So if the top of it is 80, the bottom of the wheel is 76 meters lower than that. So 80 take away 76 tells us the bottom of the wheel was at 4 meters off the ground. So now that we have our maximum and minimum, the amplitude is the maximum minus the minimum divided by 2, which is 38 meters. And our median value is the maximum plus the minimum divided by 2, which is 42 meters. So there's our median and our amplitude. Those are good things to have. And for the horizontal translation, the car is at its lowest point at t equals 0. So they want us to draw one that starts at a minimum. So quick, what kind of trig function should we use? If we want a curve that starts at its absolute lowest point, which trig function does that? There's only one. We have to use negative cosine. Remember, the negative cosine is the only wave that starts at a minimum and then it goes up and back down, exactly like a Ferris wheel does when you get on at the ground level and then go up to the top and come back down. We have to use something that has a negative cosine in it to make this graph work. And if we do that, then our starting point is exactly at 0. So it's actually nice to use a negative cosine because that way we don't have any horizontal translation. Our C value is just zilch. That saves us a little bit of trouble. Now we need a B value. Any idea about that? They say here the wheel rotated every 9 minutes. That means the period was 9. And our B value will be 2 pi divided by 9. You've seen a few examples where we leave that alone as 2 pi over 9, but I'm going to take a chance and do actually 2 pi divided by 9 and get 6.98 this time. We'll see if that is any nicer to work with. So our B value is 0.698. So now we're ready to set up an equation if they want one. And using the data on the table up here, we should have enough to sketch this thing's graph. We know that at the very beginning, it was 4 meters off the ground. We know that in 9 minutes, it has to have gone through a complete cycle and again be 4 meters off the ground. Halfway through a cycle, so at 4.5 minutes, it has to be at its absolute maximum, because these waves are symmetric, and the highest it ever got was 80 meters, so there we are. There's our max. A quarter of the way through, so at 2.25 minutes, and at 6.75 minutes, these are our quarter points. It should be exactly halfway up, or exactly in the middle, which is, for us, 42 meters. So there's a point, and there's another one. Okay, remember what I said about quarter waves? If you have the entire wave broke up into quarters, then you've got from a valley to the middle to a peak, back down to the middle, and back down to a valley. Each of those is a quarter of the wave, and they're very good landmarks. So now if we draw this, it should go up to the middle, and then it should go to a peak, and then, whoops, should come back down to the middle, and then it should drop. And a full cycle should look something like that. We have our maximum at 80, our midline at 42, and our minimum at 4 meters. Now, determine the equation of the graph in the form la 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 la. Okay, well, we've already got all the values we need to do this. Just, we worked them out in the process of setting up our graph, so this should be a snap. Our amplitude is 38. So our height is, remember we started at a minimum, we have to say minus 38. Because regular cosine starts at a max and then drops. We want one that starts at a minimum and then rises. We need to flip it upside down, and this negative is what does it. So negative 38 cosine. Our b value was 0.698, I believe. Yeah. 0.698, open parentheses, t. I'll put minus 0 just to remind you, but there was no horizontal translation. This wave starts exactly where a negative cosine is supposed to. And then our d value, the midline, is 42 meters up. So there's our equation that matches this curve. Now, how high is the cart 5 minutes after the wheel starts rotating? The quick and easy answer for this is find 5 meters, read up to the graph. You can see it should be in the high 70s meters. But let's do it algebraically, like good mathematicians. We'll take 5 and feed it into this equation. I'm going to use this space because it's getting a little cramped down here. So our height should be minus 38 cosine 0.698 times 5 minutes plus 42. I'll remind you again, please be in radian mode when you do this calculation, or else the cosine won't come out right, and you won't like what happens then. So 0.698 times 5. Make sure you're in radian mode, hit cosine, multiply by negative 38, and add 42. 77.7 meters, and that fits very nicely with what we got from the graph above. Okay, now, how many seconds after the wheel starts rotating does it get 10 meters off the ground? Again, the quick and dirty answer is we go to here, we get like 1.1 minutes, and so we say about 1 minute and 6 seconds. But let's do it algebraically, and we'll see if we can get that answer again. If we want the height to be 10 meters, then we take this height equation, and we say if the height is minus 38 cosine 0.698 t, I'll leave out the minus 0 this time, plus 42, when does that come out to 10? So subtract 42 from each side. 0.698 t equals minus 32. Divide both sides by negative 38. Cosine 0.698 t equals, and 32 divided by 38 is 0.842. Now, the right way to do this is to draw axes and figure out what two quadrants we're in, etc., etc. But they only want the very first time that the cart gets to 10 meters off the ground, so I'm going to take a chance on just solving this without doing my and assume that we're in quadrant 1. Cosine is supposed to be positive here, so I think it will be in quadrant 1. I think we can get away with this time. I'm doing this because I'm running out of space on this page, and I don't think I have room to do the diagrams, and I think you've seen them plenty of times. You're probably tired of hearing me talk about it. So, make sure you're in radian mode. Do the inverse cosine of 0.842, and you get 0.698t equals 0.570. Divide by 0.698, and you get that the time is 0.816, and that's minutes, because this graph normally wants to give minutes. But wait, they don't want minutes, they want the time in seconds, so 0.816 minutes times 60 seconds per minute gives us 48.98. I basically get 49 seconds to get to the 10-meter mark. Now, when I did the graphical solution, apparently I didn't do all that well. I did this and thought that it would be more like a minute and 6 seconds, so obviously I have this part of the curve not rising as fast as it ought to, but it isn't hugely off. The graphical answer I got was a little over a minute. This is a little under a minute, so not too bad.